As of 2026, there is still no peer-reviewed report of a reproducible, audited, closed-cycle device that produces net power from vacuum fluctuations. That single fact cuts through decades of free energy storytelling, and it reframes what the Casimir effect really is. Not a hidden generator, but a precisely measured boundary phenomenon. Start with what is solid. Casimir forces are real. Put two neutral surfaces very close together, and quantum fields respond to the boundary conditions. A force appears. What you measure depends heavily on geometry, materials, and calibration discipline. The hard work is not chasing a mysterious energy release. The hard work is making the experiment honest. Measurement has become impressively sensitive. In controlled setups, precision reaches the sub-piconewton range. At that scale, the biggest uncertainties are not quantum limits. They are surface roughness, contamination films, electrostatic patch potentials on neutral conductors, and thermal drift that slowly biases the apparatus. So the frontier looks like metrology and nanofabrication. It looks like ruthless calibration. That leads to a strategic takeaway. The Casimir effect is mature enough to be a reliable scientific target, but not in the way hype suggests. The maturity is in repeatable force measurement, not in energy extraction. If you fund it like an energy bet, you will probably misallocate capital. If you fund it like measurement infrastructure, you get compounding returns in instrumentation, sensing, and surface science. Now consider the theory landscape because it is broader than many people realize. Vacuum energy under boundary conditions is not one tidy formula. People use multiple tools to compute Casimir energies in bounded geometries, and they also study cases where an observer's motion changes what vacuum even means. There are simplified field models and discretized constructions that make certain calculations exact. This is not just math for its own sake. It is how the field learns which predictions survive real materials, real boundaries, and real imperfections. A particularly important line of work is stability. If you confine a region and shift vacuum energy with boundary conditions, does the setup behave benignly, or does it imply instabilities? That has been studied for decades. The key point for decision makers is simple. Even when theory explores exotic scenarios, it still does not hand you a device class that produces net power in a closed cycle. Another subtle idea is gravitational coupling. Some approaches treat Casimir energy as quasi-local and, in principle, something that could couple to gravity. That leads to concepts like vacuum buoyancy in weak gravitational fields. It is intellectually provocative, and it tightens the bridge between quantum field theory and gravity. But it does not, by itself, turn vacuum energy into an engineering energy source. The likely outcomes are effects that are too small to matter, or effects that confirm theory without changing the energy economy. So where does the excitement concentrate today? Mostly in boundary engineering. If you can shape surfaces, choose materials, and design structures that modify electromagnetic modes, you may be able to tune Casimir forces and in special configurations even change their sign. That is plausible as force control. It could matter for nanoscale actuation, precision sensors, and micro devices where tiny forces dominate behavior. But force control is not energy extraction. A Casimir-mediated actuator cycle has to pay for everything. You must include the work required to change boundary conditions. You must include dissipation in real materials and thermal coupling to the environment. And you must include every auxiliary system inside the system boundary when you claim network. This is where many public claims fail, not because the Casimir effect is fake, but because the accounting is incomplete. If you let two plates attract, you can harvest that work once. If resetting the system costs more than you gained, the cycle loses. That is exactly what disciplined experiments are designed to reveal. There is a watch item that captures the current state. In 2025, a high-visibility claim set argued that metamaterial-enhanced Casimir effects could enable macroscopic levitation and open pathways to vacuum energy extraction. It requires replication and closed-cycle energy accounting before it should be treated as more than boundary force engineering. Until independent labs reproduce the force magnitudes and signs and audit the full energy balance, it remains speculative. For leaders allocating capital and attention, keep two ideas separate. One is precision, Casimir metrology, and materials science, meaning better surfaces, cleaner measurements, and interlab comparison. The other is vacuum energy extraction, which remains unvalidated and should not enter grid models or energy security forecasts. If you remember one line, make it this.